Ladies and gents, welcome to UX, and this is Kerbal Scuffed Program 3, Kevin's Wrath. Oh yeah, Kevin fucked off in some kind of a spaceship, right? In the second one, alright. Yeah. So, Kerbal Scuffed Program, or Space Program, what is the name? Kerbal Space Program. This game is from 2011. I like how you basically, it's kind of like a simulation of how to create a rocket. You have to know all this, laws here and there. Otherwise, you would just basically crash every single time. Right, so this is really good. In the world of simulation like games, this is another addition. I've been finding out games like this a lot, right? There are lots of games that just emphasize on how to make something work, right? This is that. There's Satisfactory that I'm reacting to from Let's Game It Out or something. There's also Factorial. Many other games that just focus on making something, right? It's just great. So let's watch it.
Sponsored by World of Warships. Hello again, I'm back in KSP. But why am I here? On Elu. That's kind of far away, isn't it? Yeah, it is. Worse, it looks like we're stranded here for the foreseeable future. Great. But how did this all happen? What led to our stranding on Elu? And where is Kevin? All good questions. Well, it all began when... Hello again, gents. Welcome back. Today, we're yet again back in KSP. In this episode, we'll be making great strides in not only sending Kerbals far away, but keeping Kerbals far away. In the last episode, the bounds of science and discovery were pushed very far. New technologies were discovered, large missions were sent to the far reaches of the solar system, and society has advanced significantly. This, however, came at a cost. Many Kerbals were unfortunately turned into a grey puff of dust in the name of progress. Jeb, Bill, Bob, Val, and in spirit, Urk and Obson, because I'm absolutely not getting them back. Sorry, Urk. They've all given the greatest possible sacrifice for the sake of the program. But, we still have a long way to go. Remember, our goal is not to explore our planetary neighbours, but to explore our stellar neighbours, specifically Proxima Centauri b. In this episode, we'll be expanding our presence by building planetary bases all over the place. Not the dingy little ones we built last episode either. This time around, we're going for big lads. They won't just be bases, they'll be complexes, with their own power generation, crew quarters, mining operations, and even launch sites. Our first target is mmmm. So, let us begin. Gentlemen, this video is sponsored by Warships. Have you spent your whole life a stinky land-dwelling pleb? Are you itching for intense violence? Well, oh boy, guess what? I think it's time for you to hop on the computer, download World of Boat for free, and send some high explosives at the Japanese. Destroyers, battleships, cruisers, and aircraft carriers. A massive 400 warships, and 44 million players to send to the bottom of the ocean. But wait, there's more. The game is now partnering with Legendary Entertainment on a collaboration to bring Godzilla vs. Kong to World of Warships. What does that mean for you? Moke. Pick a side, shit lizard or giant gorilla, and unlock special rare camos, ship skins, and even Moke on the boat. Yeah! That's right, baby. He roars. Download using the first link in the description and use either Godzilla or Titan Kong for your promo code. Forget about Godzilla though, because Godzilla is a shit lizard. Enter code Titan Kong for 300 doubloons. 1 million credits, 5 days premium to USS Charleston, 10 monkey-themed camos, or Godzilla camos if you're a shit lizard fan, USS Smith, or Taichibana if you're a shit lizard fan, and 3 Godzilla vs. Kong ship crates. Gentlemen, you must act fast. This is an extremely limited event, so get your giant boat gorilla before it's too late. Offer ends 31st of May. Back to the video. So, mmmm. We're going to need a few modules for our base to be fully operational. Mining, refining, habitation, and a launch pad. But let's back up for a minute. Why build a base on mmmm?
Oh no, here it comes. He sauce.
Hello class, it's me, Frog Guy. In this lesson, we're going to learn about drag. Aerodynamic drag. Drag is a force that acts in the opposite direction that you're moving. If I move to the right, then I'll experience a force to the left. It slows stuff down. Not what we want for high-speed rocket flight. Or is it? Yeah, most of the time. But parachutes are very useful because they can create huge amounts of drag when you want them to, slowing a speedy craft down to not so speedy speeds. But, most of the time, drag is bad. So how do we get rid of it? Well, if we can find a way to lower these guys on the right, it'll result in this guy on the left also being lowered. Maths. Now let's say, hypothetically, I want to have no drag whatsoever. Since all the terms on the right are multiplied together, and we know that anything times 0 is 0, if any one of these numbers here is 0, then the whole thing is also 0. These guys on the right here can't really be 0. Area would mean our craft is a one-dimensional line, the drag coefficient can never really be 0, and if you made velocity 0...
Exactly, how the fuck you gonna do space, how you gonna make spacecraft 0? It can't be a line.
Well, yeah. Last we could change would be fluid density. Now this can actually be 0. Now I wonder, where is fluid density 0? Kevin. I mean, someone. Please tell me.
He's
really?
Missing Kevin.
No one? Guys, come on, it's Minmus, you fucking idiots! I've had enough. God, why would you just pay attention to what I... Yeah, Minmus. There's no atmosphere, meaning drag is 0. Good spot for a base, don't you think? Yes. So we want to build a base. What do we launch first? Simple. 3 things.
Yeah, I mean, obviously, other planet that has no atmosphere, that's where he was going. I'm like, what the fuck, why is he gonna do this? What is he talking about? 0, how are you gonna make it 0? But yeah, you just go on a planet that is no atmosphere. Yeah, that makes sense. That is why everybody wants to make a base on moon, right? As a, basically, your traveling thing, right? If you want to go to, I guess, you know, like he said, Proxima B in real life, you would basically launch from the moon rather than Earth, because Earth is way costly.
At the same time, because otherwise we'd be here for far too long. The main habitation module, called Djibouti, the beam sections on the side, called Djibouti beam section, and the crane. Except the crane didn't work, so we went for this thing. The amazing, the incredible, Big Nuts. Big Nuts will attach the beam section to the habitation module. So, let's launch.
3, 2, 1, go!
And they're all here. After several minutes of futzing around with big...
The landing was a bit hard, don't you think? Real life, if that shit happens, it would explode.
nuts and a couple of Kraken encounters, the beam sections were fully assembled. So, what next? Well, we're close to completely out of funds which are needed for expanding the base. So what do? A. Collect some easy money by completing contracts. B. Sell off some science and reputation for a quick fund boost. Or C. Liquidate all capital assets and divert the funds into a multi-billion-dollar joint venture with Amin Hassan Nasser, president of Saudi Aramco Petrochemicals, to build the largest, most powerful, and most profitable chemical refinery ever built. I think the answer is pretty clear.
Yeah, it's C.
After an hour of turning ore into monopropellant, or cash into more cash.
Basically, just answer major scale construction, partnership right there. Oh, look at that. You're gonna basically partnership with that. Yeah, I need to make this into bigger one.
We have arrived at 5 million funds. More than enough to make the rest of the modules for the base. However, we have a problem. It turns out where we put the base is quite important. There are two main resources we need for it to function. Ore, which is used to make fuel, and metal ore, which is used to make metal, which is used to make rocket parts, which is used to make rockets. Our current spot has ore, but no metal ore. So I did some prospecting, found a good spot, built a sky crane, flew it to Minmus, picked up Djibouti, and flew it about 20 kilometers east. Our new spot is rich in both ore and metal, but it's not flat and tends to cause, problems. To complete the base, we need a drill rover, a refining rover, lots of these attacher things that are unnecessary if you aren't stupid, and finally, the launch pad. And there we go. In celebration, we build a fuel tank, and a dish, and a station. Why? Well, as my new Saudi friends would tell you, because we can. This Minmus base will be our new point of rocket.
Oh my god. First of all, this game looks so good, not because of its graphics and texture, just because the shades of it, right? I like how the background is properly dark. Look at this shit. See? You can kind of see small stars, like how the, lunar images are, right? There's a full controversy, like, okay, this is a fake landing, you don't see stars, but you can't see it here. But if you really look at it, you can barely see it, because this is so bright. I like how they capture that, and you don't just see, lots of stars in the background.
Launching. And our first mission from it will be Gilly. If you think Minmus's 0.05G is far too much gravity, try Gilly with its 0.005G. That's 10 times lower. Not only is the gravity incredibly low on Gilly, but it's quite far away, so being able to build things there is a big, fat dub. This time, I'm going to send a single rover that can do all of the functions of the Minmus base, but badly. This rover will be the start point for yet another base. Its name?
Yep, that's about right.
Instead of launching from
I was gonna keep
Kerbin
that
with a
title
huge
on.
annoying launch vehicle, we can simply build it on Minmus and ship it to Gilly from there. Not only will this be easier, but it also won't cost any funds at all. Not that that matters. After a painful construction process, it's on the pad, fueled up, and ready to launch. So, let's launch. There we go, boys. One has landed. As a test, I quickly whip up a small science rover, build it up, and drive it around. However, around this time, this started happening. Repeatedly. I switched to the Minmus base, and then this happened. Oh shit. Not good. Luckily, I had turned quick saving and reverting back on because of this exact bullshit being a possibility. So the bases weren't gone.
Okay, so it didn't have quick save on. I guess it's a challenge thing, but then oh, look at that, there are bugs in this. This is so fucking good, right? In this game, you have to be precise at a certain moment. It takes time to do something, preparation, and in the end, some bug basically blows your fucking thing up.
Reverting back on because of this exact bullshit being a possibility. So the bases weren't gone, but they were kinda useless in this state. Dang. So for the next base, I decided I would... For this base, I've made the executive decision to launch it from Kerbin. I had a plan for this particular vessel, and it was big. Luckily, our boys at Saudi Aramco had been pumping and dumping non-stop for the past several months, netting us a very, very large amount of funds to work with. 26 million to be exact. Excellent. This would be necessary, as this next base would be quite large. So large in fact, that 26 million wouldn't actually be enough money. Now, we could have continued to convert Kerbin's crust into monopropellant until we reached the planet's core, but that would be boring, and I know we can do better. What we needed to do was find a different resource to sell. You see, our great, strong partnership took boring old ore and converted it into boring old monopropellant. This would be the most efficient conversion without mods, but we have mods, so let's use them. Behold, the different resources of KSP Interstellar. There are a lot of these, and some of them are worth quite a bit of cash, but one stands above the rest. Antimatter. 1 kilogram of this stuff is worth a ridiculous 108 million funds.
Yeah.
However, we can do even better. This is the diamagnetic Antimatter Container, which doesn't just store antiprotons, but full antihydrogen, which you can store with much higher density. In fact, right here, you're looking at 1,000 kilos, or 1 ton, of antihydrogen, which is worth 108 billion funds. Now that is a lot of dollar. So, let's partake in the ultimate drug run and go fill it up. But first, what is antimatter? Hello again, class. Welcome back. Particle physics. Sounds complicated, but it's really not that bad. Firstly, We begin with water. If you were to zoom in really close to water, you wouldn't see anything. But if you could see something, you'd see water molecules. Lots of water molecules. Let's pick one of these molecules and look at it even closer. At this scale, you can see that water is made of 2 hydrogen atoms and 1 oxygen atom. H2O. Let's ignore the oxygen for the time being and zoom into one of the hydrogen atoms. At this scale, we see that the hydrogen atom itself is made of 1 proton and 1 electron. Protons have mass and a positive charge, and electrons have almost no mass and a negative charge. Protons and electrons, and also neutrons which have no charge, make up matter. If we have a close look at oxygen, we see that it itself is made of 8 protons, 8 neutrons, and 8 electrons. So where does antimatter come in? Well, it's basically the opposite of regular matter. Antiprotons have negative charge, and anti-electrons, which are actually called positrons, have a positive charge. This means that antiparticles and regular particles are attracted to each other. So, what happens when they touch?
Yeah. And neutrons can also have antimatter type of thing, but it's you have to look at the quarks inside, right? That would have opposite charges.
Annihilation. All their mass gets converted to energy by Einstein's famous equation E equals mc squared. E being energy, m being mass, and c being the speed of light, which is squared. C squared happens to be this number, 9 with 16 zeros on the end. So if you had 1 kilogram of antimatter and mixed it with 1 kilogram of regular matter, you'd have this number of joules. A lot of joules. Or 21 megatons of TNT in 1 kilo. Pretty good stuff. Which means our lovely 1 ton of antimatter is the equivalent of 21 gigatons of TNT. Very big. But still 5,000 times less than the Dino Destroyer asteroid. Now that was a big boy. Back to the challenge at hand. Collecting antimatter. Challenge number 1. You can produce antimatter in Kerbin, but it's difficult and slow. Not ideal. The other way to get antimatter is through using a collector. In space, there's actually a fairly large amount of antimatter just floating around. If you're smart, you can use strong magnetic fields to capture this antimatter and store it. This is great, but it only works in space, and works best near strong magnetic fields where there are lots of particles whizzing around. Kerbin has a magnetic field, but it's quite weak. So do all planets in KSP. But they all suck compared to our big green friend, Joule. At exactly 9,000 kilometers in altitude, on a perfectly circular, 0-degree orbit, you can get the highest possible antimatter flux. You can also stack up collectors.
Yeah, okay. I don't know how close this is to our real world, basically physics. People say it's a bit different, right, in the game. But yeah, obviously antimatter, you can collect that, right, using electromagnetic field. But using antimatter in a real physical way, it's not so fucking easy. I said that in one of the other videos, I guess it was Seth video, where I said, doing something with the antimatter is not easy. And people are like, you can store it. Yeah, but you're just focusing on the storing, yeah, right? Storing at a stable state, like they're like just storing at one place. That is complicated itself, but yeah, you can do that. But actually applying it, using antimatter to do something, that's not easy. But I guess in this world, probably you can do that.
And start collecting in the tens of grams per hour. Big stuff. However, there is another problem with this method. The collectors can only collect antiprotons, not positrons, which can only be created in a cyclotron. So, we need lots of collectors, a cyclotron, a power source, generator, radiators, and of course, engine for getting to Joule. Behold, the Warren Buffett. Let's strap it to the most powerful rocket ever built and send it up.
It's so good, all the naming. Pepsi, man.
Once at Joule, we place ourselves at 9,000 kilometers, start producing positrons, and begin the lengthy collection process. And after a mere 6 years of spinning around the big green boy, the container was filled with a ridiculous 1 ton of antimatter. Time to bring it back to Kerbin.
First of all, antimatter is so expensive because there isn't many of them to sell, right? If you bring in 1 ton of antimatter, it wouldn't have the same cost as it has right now, right? It's called basically inflation. And who are you going to sell all this money and all these billions of dollars worth of antimatter, right? They're not going to pay you that much, right? It's like, okay, come on.
After another 2 years in space, the massive bounty of antimatter is finally back. So we recover the vessel and are rewarded with 96 billion funds.
96 billion.
Very good. Now that we will never have money problems again, we can begin construction of our largest project.
But this is basically the example of how people say whoever is going to dominate space, whoever is going to mine the first asteroid is going to be trillionaire. Yeah, kind of true. Look at that. This is kind of an example of that.
Yet, the dual spacecraft. Since it's going to be so large, launching it in one go would be infeasible. So instead, the program has decided to launch it in several smaller chunks and perform what is known in the business as orbital assembly. This would require many launches, but once assembled, we would have a real big boy in space. Not just any big boy either. This would be a proper spaceship. Lots of fuel in these spherical tanks, this big fusion engine for high efficiency, a nuclear reactor for power, a ring centrifuge particle accelerator.
I don't want to pause too much, but this orbital assembly, right? This thing is, I guess, whenever somebody's come forth with some kind of some kind of idea like that, you're like, okay, maybe until it happens, it's just an idea type of thing, right? But James Webb was kind of like an assembled type of thing, right? Its wings were kind of inside, right? And then it kind of opened up, right? We actually did that shit. So, assembling the space is not just an idea. You can actually do that shit.
A thing that looks cool, and a lander for collecting surface science. But before we launch, learn time. Let's rewind the tape a little bit. This big fusion engine for high efficiency. What do I mean by this? What makes a rocket engine efficient? First of all, let's look at a small example. These two rockets are both exactly 7 tons and have the same amount of fuel. The only difference between them is the engines they use. This one uses a conventional liquid fuel engine, and this one uses a nuclear engine. If we burn all the fuel in both rockets, which one will be going fastest at the end? The nuclear engine, obviously. Why else would we put a nuclear reactor in space? You dumb. So why is this? Conservation of momentum. You may remember back in
obviously fusion is going to be more efficient than combustion, right? I mean, combustion feels like primitive when we talk about fusion. I mean, the star works with fusion, right? That is the literally meat of the entire universe's energy, right? I want to say the biggest energy there, but then somebody's going to be, there's this different type of time. There's black hole engines, this and that. There's going to produce more energy, this and that. Yeah, but the meat of the universe is stars. The stars work by fusion, so yeah. So basically, fusion engines is not that far-fetched, right? It's going to be hard to make it, I guess. It's going to be very costly. It's not going to happen anytime soon. But basically, if you create a nuclear fusion reactor, right, give it some kind of a liquid that it can actually heat up and burn and the gases come out, that's going to be much faster and efficient.
Episode 1, when I asked Kevin about Newton's third law. Every action has an equal and opposite reaction. The rocket engine expels hot gas backwards very fast, which imparts an equal and opposite force on the rocket, causing it to accelerate. If you throw the hot gas back even faster, then you get more force for the same amount of fuel. This is exactly what the nuclear engine is doing. It uses a nuclear reaction in its core to heat up a gas to incredible temperatures that are much higher than what normal chemical rockets can achieve. This hot gas expands more than regular hot gas, which gives it higher exhaust velocity, and thus higher efficiency. So what about our futuristic fusion rocket? How does that work? I don't know. But what I do know is that it uses a nuclear fusion reaction to release lots of energy and then shoots hydrogen through it to get its thrust. Efficiency is measured in specific impulse, which is measured in seconds. Higher seconds is better. But why seconds? 400 seconds would mean that a rocket engine with 100 kilograms of fuel would produce 100 kilograms of thrust for 400 seconds before it ran out of fuel. The best chemical rockets can do about 400 seconds of specific impulse. The nuclear rocket engine in stock KSP does 800 seconds, and the ion engine can do 4,000 seconds. This is still baby shit though. The fusion engine that we've been talking about can do 15,500 seconds in high thrust mode, and 27,000 seconds in the most efficient mode. But we can do even better. The best engines can do 100, even 200,000, with the very best able to do a ridiculous 2 million seconds of specific impulse. These engines are so powerful that they can realistically accelerate the craft to a significant fraction of the speed of light.
Yeah.
Very nice. Anyway, back to the Joule mission. We've got a few modules to launch: propulsion, command, centrifuge, reactor, habitation, labs, new labs because the old ones are bad, and the lander. So, let's go. Once the spaceship was fully assembled, I went to give it a name.
Oh my god, I love this game so much. I love every time a rocket basically launches and it just comes out of atmosphere, right? You see the sun in the background and how the planet looks changes as soon as you go up. Because let's be honest, this is how our eyes would see it, right? Things suddenly lit up on the terrain and it kind of blends in because our eyes basically adjust to things, right? It can't see that much detail from top up. So I like planet is just too much detail. As soon as you go up, it starts to light up because atmosphere kind of lights up. There's a sun behind it and everything just kind of blends in. That is so good. I like the whole element of how they capture this, right? I'm not gonna say the textures and everything is ultra realistic like some top, AAA game, right? It's not, but things that are captured there is so good. Some of the details are incredible.
But what to name it? Something that is definitely the Big Funny. I consulted the world map, zoomed into West Africa, into Burkina Faso, and to its capital, Ouagadougou. Immense. Once around Joule, we placed the craft into a parking orbit, detached the lander, and began the hunt for lots of science.
Music is great. The level of fast launches and fast landings and fast research is happening right now. Yeah, this is what NASA would use as a pawn, right? Oh yeah, this is the stuff right there.
Lots of data was collected, and our fuel was almost depleted. We headed back to Ouagadougou, docked, and transferred the science into the lab. After several more months of zooming around the green boy, the research had been completed. In total, we had collected 41,000 science from our mission, but the labs had multiplied this by 5, leaving us with an absolutely massive 207,000 science. In celebration, I get a Kerbal out of the habitation module, who is instantly vaporized by the high-energy neutrons from the fusion engine. RIP. I hurried to the R&D building and unlocked every...
So let me get this straight. He created a fusion engine and didn't see the side effects from it, right? Like this can be hazardous, like how to create safety measures. He didn't do none of that shit. Oh, look at that. Nuclear fusion engine, right? Let's research it and let's put it into effect. Yeah, what about the safety protocols? What safety protocols?
every technology available, including the warp drives. Our next base will be on the surface of the furthest planet in the Kerbal system. Good old Elu. I've learned from our previous surface-based mistakes and placed everything necessary for the base to function on one vessel. Its name... This long boy has the premier in power generation, a literal black hole, and many other important features like a launch pad, drills, and an ISRU module. The interesting part of this base is how we're bringing it to Elu. You'd expect for a rocket of this size it would need a massive launch vehicle, but no. With our shiny new technologies, we can condense this vehicle into this power node. It uses 4 antimatter powered jet engines, a massive fusion engine, and the warp drive. So let's launch.
How is it gonna look? Okay.
Up in space, we don't bother getting into orbit. Instead, we begin charging the warp drive, and...
Damn.
20 minutes later,
I don't see much of warping there. So how is this a warp drive? I guess it's just like really fast drive or something like that.
Traveled 76 million kilometers, and we're here. We take it down to a low orbit, and touchdown. In less than a week, we've placed a base on the furthest planet in the solar system. Very nice. In celebration, we build a space station and launch it from our base. Incredible. We've pretty much conquered the entire solar system, so naturally, our next destination is... For our first interstellar voyage, we'll send a lander to plant a flag on the planet's surface. This will need an interstellar transfer stage, and a lander with enough delta-v to land and return to orbit. For this job, we've recycled the Ouagadougou lander, remembered to include a ladder, and built the very first interstellar transfer stage. So, we put it on a launcher, name it Shitfart14, and launch.
That's right, Shitfart.
Once in space, we charge up the warp drive, and...
Dad, look at the inside of it. Alright, first of all, I want to say the nuclear engine, right? Oh, wait a minute. So yeah, what I was saying was, yeah, fusion engines, nuclear engines, right? So nuclear engines is a problem, right? If you go really, really fast, like very close to the certain portion of speed of light, one simple asteroid rock here and there that you can't see in this kind of a space, right? When you're going that fast, and the impact speed would be so great that you would instantly explode, right? I want to say it would be worse thing with the warp drive, but maybe not, right? There is a theory that with warp drives, it actually warps the space around you, right? You're not traveling through space, you're warping the space around you. So if there is even a dust particle there, it's not going to hit you. That is just going to warp around you and just go away. So technically, if you hit a planet, you're not going to hit the planet, you're going to go through or something like that. I don't know. But that's just a theory. If that happens, warp drive is kind of, doable, even if it's doable with science, right? But if that's not the case, you don't warp the space around you, then warp drive is extremely dangerous and probably going to have 99.9% fatalities or something. One dust particle would explode the whole fucking rocket.
Here we are, boys. Proxima Centauri. And our small exoplanet, Proxima Centauri b. We detach the lander and fly it down to the surface.
Closest planet to us. Wait, what? Is that Kevin? Kevin's already here. Okay. Of course he is. What the fuck? Kevin just went stone cold. Ah, damn. I kind of knew that coming, right? As soon as he's gonna reach, somehow Kevin beat him to all this, right? Kevin had all the funds. If Saudis were backing Martin here, who was backing Kevin? United Emirates or something. This is so good. Alright, people, that was Kerbal Scuffed Program 3, Kevin's Wrath. By the chap martincitopants. I hope he does more of this. People are telling me that he's doing it, I guess. Right, if you like my reaction, don't forget to subscribe. Check out the reaction, there's a link in the description. Check the cards, comment down if you want to react to a specific video from this channel or any other. And yeah, I'll see you next time.